Morning, class 10th. We are going to do some further work on reflection in coordinate geometry. We did certain questions. I'm going to do 3-4 more questions for you in reflection, and then we do the section formula today. Now, like, first question is use graph paper, and he has given you the scale. He has given you the scale. As I said that he can give you a scale and he may not give you the scale. So it depends upon you. If he's given you the scale, then we will use the scale which is given by them. Like he has given a scale 2 centimeters is equal to 1 unit. That means what? That means the distance between this point and this point, all the consecutive point is 2 centimeters. This is 2 centimeters. This is the distance between 0 and 1 is 2 centimeters. 1 to 2 is 2 centimeters. 2 to 3 is 2 centimeters, and so on. Similarly on minus side, similarly on the y, along the y-axis, along the x-axis, the same scale is being used. He says plot the points. ABCD is a quadrilateral with vertices 2, 2. 2 means it will be in the first quadrant. X is 2, y is 2. So here is 2. That means it is a 4 centimeter, and it is also 4 centimeter because it is 2, and we are using 1 unit as 2 centimeters, so it is 4 centimeters. This is 2, 2. Don't worry about 4 centimeters, just talk of the plotting the point. 2, 2. B is 2 minus 2. 2 minus 2. Actually, it is the reflection of A reflected in B in x-axis actually. B is the reflection of A in x-axis, because we told you when we reflect a point in x-axis, the sign of the y-coordinate changes. So 2, 2 becomes 2 minus 2. But he is asking you to plot. He is not talking anything about reflection. So we are plotting. Then 0 minus 1. 0 minus 1 is here, and 1, 0 is here. These are also C and D are reflection of each other in x-axis. C and D are also reflection of each other in x-axis, because this is the x-axis. Now he says once you've got the quadrilateral A, B, C and D, he says reflect this quadrilateral in y-axis. Reflects this quadrilateral in y-axis. So I reflect this quadrilateral in y-axis. When we reflect a point in y-axis, the sign of the x-coordinate changes. B will become B dash as minus 2 minus 2. A would become as minus 2 and 2. And since point D and C are on y-axis, any point on the line, if we are reflecting a point on the line itself, then that point is called invariant. So C and D are the points which are on the y-axis, and we are asking to reflect them on y-axis. So these are invariant point. C and D are invariant point under reflection in y-axis. They are invariant point under reflection in y-axis. Now look at the figure. We have got this whole figure. It looks like a butterfly actually if you look at that. But he says reflect ABCD in y-axis. Name it A dash, B dash, C and D. C and D are not changing because they are invariant point. They are invariant point. They are not reflecting. They are being reflected on the same line where they are lying. So obviously they will be invariant point. Now the next is write coordinates of A dash, B dash. We have written the coordinates of A dash, B dash. Name 2 points which are invariant under reflection. Now in this reflection, C and D are invariant. C and D are invariant. Invariant in reflection and y-axis. Invariant in reflection, because we are doing the reflection in y-axis. So invariant and reflection in y-axis. In y-axis. They are invariant under reflection in y-axis. And he is asking that invariant under reflection is being done in y-axis. Then he says name A dash, B dash, C, D as geometrically. Name this geometrically. What is this figure A dash, B dash, C and D looks like? It is a trapezium. It is a trapezium. A dash, B dash, C, D is a trapezium. T-R-A-P-E-Z-I-U-M. Trapezium, whatever you want to call it, different pronunciations of it. Trapezium. Now, trapezium is a quadrilateral having a pair of opposite sides parallel but not equal. A dash B dash is parallel to CD, but they are not equal. They are not equal. So it is a trapezium. Actually, it is an isosceles trapezium. Why? Because if you see A dash D and B dash D, non-parallel, B dash C, non-parallel sides are equal. Non-parallel sides are equal. The parallel side cannot be equal. If the parallel sides are equal, then it will become a parallelogram. But here the parallel sides are there, which are not equal in length. That is why it is a trapezium. It is not necessary to have these two non-parallel sides equal, but in this particular case, non-parallel sides are equal, and when the non-parallel sides are equal, it is known as an isosceles trapezium. So this is a trapezium. Actually, you can name it isosceles if you want to, but trapezium is alright. Now let us see question number 2. This figure I have drawn here, but I'll be putting it in the form of a scanned copy at the end of this chapter, the actual diagrams which we have drawn on the graph paper, so that you get the correct idea. Now let us see the second question. He says the point P 2 minus 4 is reflected about the line x is equal to 0. Now let's draw x-axis and y-axis. One, two, three, 4 it is. Minus 1, minus 2, minus 3. He has not given you any scale, so I'm taking 1 centimeter is equal to 1 unit. So 2 centimeter is equal to 2 unit. I'm taking 1 centimeter is equal to 1 unit. Now it says the point P is 2 minus 4. The point P is 2 minus 4. This is the point P, 2 minus 4. P is 2 minus 4. The distance perpendicular here, and this is point P, 2 minus 4. This point P is 2 minus 4. P is 2 minus 4 is reflected about the line x is equal to 0. X is equal to 0 means y-axis. X is equal to 0 means y-axis. On x-axis y is 0, that is why this line is called as y is equal to 0. And on y-axis x is 0, that is why it is called y-axis is named as x is equal to 0 also. Now this point P is reflected in line x is equal to 0, which is y-axis. It is 2 minus 4, so it will become minus 2 minus 4. It will become minus 2 minus 4, because when we reflect a point in y-axis, the sign of the x coordinate changes. So P dash, he says, to get image Q, it is image Q, and its coordinate will be minus 2 minus 4. Its coordinate will be minus 2 minus 4. Point Q is reflected about line y is equal to 0. Y is equal to 0 means x-axis. Y is equal to 0 means x-axis. Now this point Q is reflected in x-axis. It is reflected in x-axis, so it will become minus 2, 4. It will become minus 2, 4. And then he has named as a R. It will be minus 2, 4. So P point reflected in y-axis, then Q reflected in x-axis, and he says name the figure PQR. Name the figure PQR. Now PQR is a right angle triangle. PQR is a right angle triangle. PQR is a right angle triangle. Name the figure PQR. Find the area of the triangle PQR. Find the area of the triangle PQR. How do we find the area of the triangle PQR? Half base into height. Area is half base into height. Here base is, this is the base, 2 plus 2, 4. Length is always plus. So this side is 2, if this side minus 2, if you add them, it will become 2 plus 2, 4. And height is 4 here, minus 4 here. Don't add them to be 0. Height can never be 0. It has to be 4 plus 4, 8. So 2 2s are 4, 2 8s are 16 unit square. Square unit. Unit square or square unit. We will be giving, as I told you in the first question also, this question also, we will be scanning the actual diagrams which I have made and will put it at the end of the chapter for your benefit. Now, alright, now let's see the next question. In every graph paper, in every reflection question, he's writing use graph paper. We have to use the graph paper wherever he says. For example, in this question he says, use the graph paper, so I'm going to first plot the axes. 0, x, O, x, x dash, y, y dash. Let's see, the point is 5, 3. So 1, 2, 3, 4, 5. He's not using any scale. So we use the scale 1 centimeter is equal to 1 unit. Let's plot it. 5, 3. P is 5, 3. So 3 parallel to this here. P is 5, 3. Point P is 5, 3. Then he says this point P is reflected in the origin to get the image P dash. Now P is reflected in the origin. When we reflect a point in the origin, both the signs of the x coordinate as well as y coordinate changes. So it will become P dash will become minus 5, minus 3. P dash will become minus 5, minus 3. Both the signs have changed. Now he says if M is the foot of the perpendicular from P to x-axis, from P to x-axis, M is the foot of the perpendicular. So this is M, and the coordinates of M will be obviously 5, 0, because it is on x-axis and it is at a distance 5 from the origin. If N is the foot of the perpendicular from P dash to x-axis, so this is the foot of the perpendicular N, and the coordinates of it will be minus 5, 0. M and N are reflection of each other in y-axis. M is reflected in y-axis, you get N. N is reflected in y-axis, you get M. Now he says if N is the foot of the perpendicular from P dash to x-axis, find coordinates of N. So we have written the coordinates of N as well as the coordinate of M. The next point is name the figure PM P dash N. PM P dash N. That means I join P dash to M and P to N. This kind of diagram you will get. If N is the footer, name the figure PM P dash N. This is a parallelogram. PM P dash N is a parallelogram. Is a parallelogram. It's a parallelogram. It's a parallelogram. Now he says find area of PM P dash N. Now you can clearly see that this complete area of parallelogram is divided into two triangles, and both are right angle triangle. Let me take out the area of one triangle and double it. I'll get the area of parallelogram. Area of parallelogram will be double area of triangle. You can say NMP. NMP. An area of this triangle will be half base into height. Half base is here, 5 here, 5 this side. So half 10. 5 is here, 5 is this side, base. So 10 is the base. Half base into height. Height is how much? 5. 50 unit square. Square unit or square unit square or unit square. This is how we have done it. We have reflected according to the conditions what he has given. We obtain a figure parallelogram, area of parallelogram. We have used this triangle. You can use the other triangle. There are two right angle triangles which are congruent and which are half. Because the diagonal of a parallelogram divides the parallelogram into two equal areas. So I took out one area and doubled it. This area was half base into height, half 10 into 5. Sorry, half 10 into 3, not 5. 5 is not the height, 5 is the base. So it is 30 unit square. It is 30 unit, 3 is the height. This is the height. 3 is the height. So half into 10, half will cancel with this 2, 10 into 3 is 30 unit square. So we get the area of the parallelogram is 30 square units. Now let us see last question in this. This is plot 6, 4 and 0, 4. Again we have to use the graph paper. One, two, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, minus 1, minus 2, minus 3. I am taking the same scale, 1 centimeter is equal to 1 unit. I am plotting 6, 4 and 0, 4. 6, 4 is here, A, 6, 4, and B is 0, 4. This is B, 0, 4. Should come here. We have plotted A and B. A is 6, 4, B is 0, 4. Reflect A and B in the origin to A dash and B dash. Now these 2 points will be reflected in the origin. If you are going to reflect A in the origin, you will get minus 6, minus 4. So I have to go here, minus 5, minus 6 and minus 4. So you will get A as A dash, minus 6, minus 4. When you are reflecting in the origin, both the signs will change. Also B 0, 4 when reflected in origin, obviously 0 remains 0, it will become 0 minus 4. So it will be B dash, it will be 0 minus 4. It is reflected in x-axis. No, in the origin. Write down, reflect A and B in the origin to A dash and B dash. It is reflection in origin is the same as reflection in x-axis because it is lying on the y-axis. Write geometrical name of the figure AB, A dash, B dash. Now let us make the figure. It's a kind of parallelogram. It is a kind of a parallelogram. It is a parallelogram. It's a kind of a parallelogram. And what we have to do is find its perimeter. You have to find it's a parallelogram. You have to find its Perimeter, you see, we can't find the diagonals exactly. We don't know whether diagonals are not going to cut each other at 90 degree. So neither it can be a square nor it can be a rhombus. It is a parallelogram. Write its perimeter. Perimeter means sum of its sides. Sum of its sides. Perimeter is sum of its sides, which will be, now we have to see what are the sides. How do I calculate the side? I can calculate this side exactly. So this side will be equal to this side. This whole length from here to here is how much? This is 3. 1, 2, 3, 4. This is 4. This is 4. And this is 5. This is 5. This is 5. Yes, 4 plus 4. No, it is 8. It is 8. The complete length is 8. This complete length from here to here is 8. And this is 5. I can calculate this length. 8 square plus 5 square. 64 plus 25. Root 89. That will be root 89. That will be root 89. Just a moment. A and B are reflected in the points. A and B are reflected in the origin. A is 6, 4. B is 0, 4. They're reflected in origin. So they get like this and we get the figure. That's absolutely right. A, B, A dash, B dash, A, B, A dash, B dash. Yes, we get this figure. Find its perimeter. So we can get this length and this length, root 89 plus root 89, and the length of this from here to here. Just a moment. Let me check this question. Yes, it's a parallelogram, 6 square. It is 6 square, 8 square plus 6 square. This length is 6, not 5. 6, 6 is 36. So it will become 100. It will become 100. So obviously this will become 10, 10, and this length is 6 again. This length is 6. So perimeter will be 10 plus 10 plus 6 plus 6. 20 plus 12, 32 unit. 32 unit. Because what has happened there, this is not 5 as we are writing. This is 6. This is 6. And this was 4 plus 4, 8. So 8 square plus 6 square will give you 100. By Pythagoras, this will come 10. This will come 10. This is 6 plus 6. So 10 plus 10. Plus 6 plus 6 will be 20 plus 12, 32 unit. That finishes your part of the reflection. There can be many more questions on reflection you can do for practice, and if you have a problem you can contact us again about any problem in your book.